In today's tutorial we will have a look at a surprising mechanistic detour. So we start with tryptamine and have benzaldehyde as the reaction partner under acidic reaction conditions, and we heat it up. Finally we will get this annihilated product as the most stable product in very good yield, above 99% yield for in this case. So what's the mechanism? The first step is rather clear. We have a condensation with the benzaldehyde. We are eliminating water. This works also without the help of an acid, but it also works in the presence of a rather weak acid, since an acid will also protonate the amine. There should be an equilibrium. Yeah. And the imine is protonated, therefore we have an iminium cation, and as we know here, we have the electrophilic center, a delta plus at that carbon here, and here we have the electron-rich heterine, so this should be the nucleophilic part. So a straightforward mechanism would be this reaction. This attacks here at that central in the 2 position to give this intermediate, and then we just have to deprotonate here and we are at the final product. Nevertheless, I've put a question mark here and some brackets, and the reason is, if we remember the protonation of the indole ring system. So proton, where will it attack? Usually not at the electron pair of the nitrogen, because this one is involved in the aromatic ring system and protonation here. We have not a good stabilization of the cationic charge because there are no mesomeric structures then. If we protonate here to give this iminium, this cation, then it is stabilized as an iminium cation here. And we have one mesomeric structure. And the nice thing about the protonation in 3 position is that in both mesomeric structures, the annihilated aromatic ring is not involved. So, and this makes those 2 mesomeric structures more important than mesomeric stabilization. If we protonate here at this position, then we have a benzoylic cation, and the stabilization by mesomeric system would affect the benzene ring. So the preferred protonation position is the 3 position, as it is also the preferred position for other electrophiles that could attack the indole ring system. So we should assume, therefore, that also here this is the most nucleophilic center, although might be a bit sterically hindered. Kinetically preferred should be the connection between this carbon and that carbon in an equilibrium reaction leading to this spirocyclic system. But that spirocyclic system can't be satisfied. It is still on a high level of energy, since we have destroyed the aromatic system of that, the heteroaromatic part of that system. So, how can we get back in track? Well, simply by a Wagner-Mehrwein rearrangement. This carbon is migrating, taking that electron pair of that bond with it to this position. And well, this migration directly leads to that anticipated intermediate on the way to a product that is indeed isolated with a very high yield. Thanks for listening.